So let's work this problem. Here's our 45 kilogram crate. It's filled with $20 bills, and these two criminals are fighting over it, having a little tug of war here. And the crate is sliding to the right at a constant speed. And so if this guy's 350 newtons and this guy's pulling with 200 newtons, we want to know what is the force of friction and what is the coefficient of friction. So let's use the procedure to solve this. And let me zoom out a little bit. What is that? Oh. So, given. So draw a little sketch of the problem. And again, you don't want to take too much time with this, so you can just kind of simplify it. Say this guy's pulling with 350 newtons. You can call this F1 if you want. And then this is pulling with 200 newtons of force, that's F2. And these are just two applied forces, or two tension forces if you want to call them, but they're just pulling in opposite directions. And we know that if velocity is, we know it's sliding to the right, so V is constant. So this is, this is what I would write down. If this was in the book or on the test, this is how I would set up the problem. And so we want to find A, we want to find the force of friction, F sub F, and then B, we want to know what is the coefficient. And this is kinetic friction, obviously, because it's sliding. So let's solve it. So we want to draw a free body diagram of this guy. So I'm applying the procedure for constant force. Okay, so here's my crate. And here's gravity pulling it down with mg. Of course, the floor is holding it up with the normal force. Now we've got a 350 Newton force like this. Got a 200 Newton force like that. Now, if this object is sliding to the right, what direction is the friction going to be? Okay, sliding friction will oppose that motion, right? So it'll be to the left. So there's my force of friction like that. Now on a test, if you were to guess the wrong direction for the friction or something, but you followed the procedure, you might miss a point or two, but you're going to get most of the points. So just, if you don't know something, if you're not really sure, just go for it and show as much work as you can. Now we're going to do the next step, which is to say this is my positive x and this is my positive y direction. This is my coordinate system there. And now all I need to do is, define the force of friction. Look, I just need to look in the x direction. So let's sum the forces in the x direction equals ma in the x. Now, hey, some people are lazy and they don't write this down. Write that down, okay? Write it down. Because it tells me, when I'm looking at your test, it tells me that you know something. And I can give you points for knowing something. It says, hey, I'm going to look in the x direction. I'm going to look at all the forces in the x direction. I'm going to set that equal to, to mass times acceleration. Because when I add all the forces, that'll be equal to my net force.
Excuse the interruption. Please send your student senate representative to the library lecture hall right now. Okay. And please bring a sheet of paper and a pen or a pencil with you. Thank you.
Okay, I'll let, if you want to do that, you can. All right, so here is the sum of the force in the x. Let's go 350 newtons in the positive x minus 200 newtons minus my force of friction equals 1, 2, 3. Those are the only forces in the x direction, you see, right? And that's going to be equal to m times a. But what is acceleration in this problem? Okay, on the test, if I tell you the velocity is constant, that means the acceleration is 0. So that whole thing is 0. Now somebody said, well, the mass isn't 0. True, but when you multiply anything by 0, the whole thing, that whole term is 0. All right, so now we can get the force of friction. 350 minus 200 is 150 newtons. So therefore, we know now that the force of friction is equal to 150 newtons. So it's pretty easy. And we also know what direction it's in. You could put negative 150, but you could put a negative 150 if you want, but you've already identified the direction in the free body diagram, so I would accept that answer. Okay, now we want the coefficient of friction. Well, this is part A. So for part B, I know that the force of friction is equal to mu times the normal force. Okay, so I'm looking for mu. So I know that mu is equal to the force of friction divided by the normal force. Now look, at this point we've done this so many times that I think that I will allow you to get a little bit lazy here if you want. What's the normal force going to be equal to? Look at the picture. The normal force is just canceling out the weight. But, you know, if you don't want to do, you know, if you are confused by that, go ahead and sum the forces in the y direction equals ma in the y direction. And you look in the y direction, I've got the normal force in the positive y direction minus my force of gravity, and there is no acceleration. So the normal force is just equal to m times g. So now I can say that the force of friction I know is 150 newtons. And then my normal force is the mass times gravity. Well, the mass was 45 kilograms. G is 9.8 newtons per kilogram. Yes, you can assume you're on Earth. And when you plug all that in, 150 divided by 45 divided by 9.8, and you get 0.34. Now, the kilogram cancels the kilogram. You could put newtons per newton, that is newtons of friction for every newton of normal force. Somebody the other day asked me, I still don't understand what the coefficient of friction means. What is it telling you? It's telling you that for every 1 newton of normal force, where those two surfaces are pressed together, you get 0.34 newtons of friction. So you could put 0.34 newtons of friction for every newton of normal force, newtons per newton, but newton per newton cancels out. So you can just write it as 0.34 as my coefficient of friction. So let's zoom all the way out. Look at the whole thing. Okay. So again, if you get a problem like this on the test, and you will, use given, find, and solve. Use the procedure. Draw a picture of it. Make sure you understand what's given and what you're trying to find. Apply the procedure. And then draw the free body diagram. Identify your x and y direction. Sum the forces in the x, sum the forces in the y. And then let these equations tell you what to do. And then also you have to know that the force of friction equals mu times the normal force. If you know how to do all that, you can pretty much solve any problem, you know, where there's friction involved for this test. Okay, so, and remember there is an elevator problem, so look at the starter for the elevator problem, all that, you should be okay. Any questions? Okay.